Hello and welcome to the first in a series of blogs on learning science research, produced by the Science of Learning Partnership Schools Initiative at the University of Melbourne. The blogs are designed to help you start thinking about research evidence and how it could look in your classroom. In this blog, we'll be exploring metacognition. To begin to understand the term, it's helpful to break it into two parts. Cognition refers to the way we interact with incoming information, including attending to it, recognizing its importance, encoding or processing it in a way we can understand, storing it in our memory, retrieving it at a later time, and using it effectively. Meta is a prefix of Greek origin, indicating that something is above or a layer of abstraction beyond the original concept. In this case, metacognition refers to thinking about thinking. It's what we know about how we think, or our cognition, and how we use knowledge of our own learning to guide future learning processes. But metacognition is more than just thinking about thinking, and there are three elements typically associated with it. These are knowledge of strategies, knowledge of the task, and knowledge of the learner. Typically, metacognition is thought of as knowledge of learning strategies that work in a particular context. As an example, consider a Year 8 student who is studying history. If the student has strong metacognitive knowledge, they might know that a graphic organizer such as a mind map is a useful way for them to effectively organize and consolidate their knowledge about the Ottoman Empire. However, there's more to metacognition than just knowing which learning strategies work. A student with strong metacognitive knowledge also knows when to use each strategy. Is it effective in both history and maths tasks? At the start of a unit and also at the end? Task difficulty is another important factor in knowing when to use each strategy. It is a skill to be able to look at a task and decide which features make it easy or difficult and select a strategy as appropriate. Students with metacognitive knowledge may also be aware of their own strengths, weaknesses, and beliefs about learning. Do they find written tasks more difficult than solving equations? Are they confident in their ability to take effective notes? Early primary students, for example, are usually unaware of their own abilities to recall something after it's studied. The Year 12 student who believes they can cram everything effectively the night before an exam probably also has low metacognitive knowledge. These three parts of metacognitive knowledge, knowledge of strategies, knowledge of the task, and knowledge of the learner, work together to help students regulate their own learning. Another element of metacognition is metacognitive skill, being able to actually put the above knowledge into practice to plan, monitor, and evaluate learning. So what does the research say? There's a large and growing body of evidence to suggest that metacognition has a medium to large positive impact on student learning. Often, the biggest impact is found when encouraging students to plan and organize their learning, including planning which strategies to use and when. Here are some resources that might help you further explore the evidence. The Education Endowment Foundation's Evidence for Learning website contains a wealth of information about the effectiveness of metacognition and self-regulated learning. Another good resource for evidence on educational interventions is the Visible Learning MetaX website. It's a free online resource that brings together a great deal of John Hattie's visible learning work in an easy-to-use online format. In the next article, we will delve further into what metacognition looks like in the classroom and expand on the idea of the self-regulated learner.